Hi guys, so I'm going to go through some equations and graphs of motion with you. So we'll just do a little bit of a recap of the equations that you've come across at National 5, and then I'll introduce you to some new ones for higher. What I'll also do after, alongside this video, I'll put the PowerPoint itself up so you can have a wee look at your leisure, and I will put the formula sheet for higher physics up as well, because you'll need that. Usually I'd print it off and hand it to you. Obviously I can't do that just now, but I will put it up on Google Classroom so that you can refer to it when you are doing your questions. So in terms of equations of motion, then we've had a wee recap on speed and acceleration, and all it is combining equations to try and work out values when we're talking about things that are moving. So in terms of revision then, let's look at this example here. So it tells you that a ball is dropped from a balcony. It hits the ground 1.06 seconds later. It wants you to determine the height of the balcony. So in terms of information, what have we got? So we've put down the first formulas that we would know from National 5. So we've got acceleration equals v minus u, so v is final velocity minus u, which is initial velocity divided by t, and our final velocity is distance over time. So we've got two unknowns here, so how would we work this out just using those equations? Well, we could work out the final velocity, because the acceleration, because it's being dropped, the acceleration is 9.8 because it's acceleration due to gravity. So anything that's subject to being dropped is obviously that acceleration is 9.8. So we've got 9.8. So if we rearrange to make v the subject, now it's got v minus u. So v minus u. Now u's 0 because initially it's stationary, so the guy's holding it and then he drops it. So the initial speed is 0. So that equals acceleration, which is 9.8 times 1.06, which we get from the question. That gives us a final acceleration of 10.4 meters per second. However, we still don't have the height, and that's what we need to find out. So what we could do is we could draw a velocity time graph, because we know that its initial velocity is 0, and then at 1.06 seconds when it lands, the velocity is 10.4, which is what we worked out from this part of the question here. Now if we drew that, we could work out the area under the graph, because as you probably remember from National 5, the area under a velocity time graph is distance. So, and because it's a triangle, it's half base times height. And the height of the balcony then would be 5.5 meters. However, this is a lot of working just for that question. So we actually have combinations of these equations that allow us to be able to work these values out without doing as much work. So if you were to combine the two then, so if you were to combine, or work this out first of all, rearrange it. So we rearrange a equals v minus u over t to make v the subject. So we end up with v equals u plus a t. I'm just going to go to the notebook and we're going to write our new equations as we go along. So v equals u plus a t, so that's just a equals v minus u over t rearranged. And then if we go back, now if we look at the area under a graph, now for this graph here, we have the initial velocity not at 0, so it's at some other value, and then going up to final velocity. And so in terms of working out the area under the graph, we would need to do the area of the triangle plus the area of a rectangle. When you do it like this and make S, which is displacement. S is the symbol for displacement. That's a new one on you. So it can get confusing because previously we used S for speed, but this is the letter that we use for displacement. So to work out the displacement of this graph, then we do area 1 plus area 2, and then you end up with, and then if you replace v minus u in terms of a, you end up with this equation. To be honest, this working out here is kind of irrelevant. Don't worry too much about it. It just gives you where this equation comes from. But if you're quite happy to just accept this equation, I would just accept it, basically. So again, we'll go back to our notebooks. We've got a new equation here. So S equals ut plus a half at squared. So u is initial velocity, t is obviously time, and that obviously would be time again. Now these would be the same because you would be using the same time. I'll explain what that you'll sort of see that in a minute when we do some example questions. And this is acceleration, and that is displacement. Okay, so that's our new equations then. So this first one, as I said, is just this rearranged. This is brand new. Okay, so you'll get this in your formula sheet. Every formula you need to use in higher will be in the formula sheet. It's just about knowing which ones to use and what they mean. Okay, so let's do some examples then using our new formula. So there's 4 examples here. The answers to them are at the bottom. You can have a go at doing these yourself, but I will go through the working on them just now. So if you wanted to pause this video now and try these questions and see if you get these solutions, and that's the equation you need to use for them, then go ahead. And then I will go through the solutions just now, so you can either pause it, try it yourself, and then have a look at the solutions, or have a look at them first and then do that, whatever works for you. So I will go through the solutions just now. Okay, so a ball is dropped from a balcony. It lands 1.06 seconds later. Calculate the height. So height is a type of displacement, it's a type of distance, and displacement is obviously the vector quantity of that. So in terms of every question you come across, and hopefully you did this for National 5 as well, but again I'll just remind you for higher, always write down what you've got. So as you read the question, write down what you've got below. So a ball is dropped from a balcony, it lands 1.06 seconds later. So t equals 1.06. Calculate the height. So it wants me to work out s, my displacement. We don't know what that is yet, but we have an equation for s, which is s equals ut plus a half at squared. Now again, if you write out that equation, it tells you what other information you need. So first of all we need to find out s, so equals u. U is the initial velocity. Well, if you think about this situation, if a ball's being dropped from a balcony, initially it's stationary because it's in someone's hand. So we can say then that u is 0 meters per second, don't forget our units. T we've got. A, well, what's the acceleration? Well, again, it's being dropped, so it's subject to free fall, where therefore acceleration is acceleration due to gravity. So it's 9.8 meters per second squared. So now we have all the information we need to be able to use this equation to work out s. So s equals, now 0 times something is obviously 0, so we can just ignore that bit, because we've got 0 times 1.06, so obviously that's 0. and then we've got a half AT squared, so a half times 9.8 times 1.06 squared gives us, now half of 9.8 is 4.9, and if we work out 1.06 squared, it is 1.12 so 4.9 times that is 5.5 meters, and if you look back to the problem answer, it's 5.5. So that's how you do that one then. So we're going to do exactly the same process for this one. So we're going to read it. So a stone is dropped down a well, it lands 4 seconds later. Time equals 4 seconds. How deep is the well? S equals UT plus a half AT squared. Again, it's been dropped, so its initial speed is 0. It's subject to free fall, so it's 9.8 meters per second squared again. So it's basically exactly the same type of question, just with different numbers. So we can skip the sort of UT bit first of all, because again we know that it's 0 times. So we just say S equals a half AT squared. So S equals a half of 9.8, which again we know is 4.9 times 4 squared. So we end up with 4.9 times 4 squared, which is 16. So 78.4 meters, and we'll check that. 78.4 meters. Okay, so last two then. So a car accelerates from rest with a constant accelerations of 4.2 meters per second squared. So for this one then, we've got slightly different information. So it's not a free fall question, so it's not something being dropped or thrown up, it's something that's going horizontally. So the acceleration is different. So acceleration for this one is 4.2 meters per second squared. Calculate the time, so we don't know that, and we know that it covers distance of 100 meters. So again, we'll do our S equals a UT plus a half AT squared. We've got A, we don't know T. U, where it says in the question it accelerates from rest, so its initial speed is 0. So we can say 100 equals, and then 0 times t is obviously 0, half times a, which is 4.2, t squared, because we don't know t. Half of 4.2 is obviously 2.1, so we end up with 100 equals 2.1 t squared. Take that to that side, so 100 divided by 2.1 equals t squared. So t squared equals 47.6. So t is the square root of 47.6, which equals 6.9 seconds. Good, 6.9 seconds. And then the very last one then, so a ball is thrown vertically down a well that is 32 meters deep. It hits the bottom. S, our distance is 32 meters, hits the bottom 2.1 seconds later. Time is 2.1 seconds. The initial speed, we don't know. So this is being thrown vertically, it's not being dropped. So the difference between that is if you drop something, its initial speed is 0, but if you throw something, you're giving it an initial speed, so that means that u is not 0 in this case because it's been thrown vertically down the well. So we will write our equation, and we've got S, we don't know U, that's what we need to work out. We've got T, and A is obviously 9.8 because it's subject to gravity. So 32 equals U, which we don't know, times T, which is 2.1, equals a half, 9.8 times 2.1 squared. You will sort of get to know, obviously, is 4.9, and sometimes you'll probably just, sorry, that's plus there. So we end up with 32 equals 2.1 U plus, we'll work out whatever that is there. So 4.9 times 2.1 squared gives us 21.6. So take that to that side, it's plus on this side, so it becomes minus on this side. So 32 minus 21.6 equals 2.1 U. So we end up with 10.39 divided by 2.1 gives us U, which is 4.95. What are we trying to work out? Oh yeah, meters per second. And if we go back to the answer, it's just rounded it up to 5. That's fine, you can do that. So equals 5 meters per second. So that is how you use this equation here then. So there is also more equations. So the equation you use for a problem is dependent on what you've got and what you need to work out. So another new equation here is v squared equals u squared plus 2as. Again, this is the proof. This is basically combining equations or sort of squaring them and getting something different. You don't need to know that. You don't need to know the proof of the equations. Again, you just need to know what they mean and how to use them. So v squared equals u squared plus 2as. So we'll go back and write this into our new equations here. So v squared equals u squared plus 2as. And again, everything's the same. Final velocity, initial velocity, acceleration, displacement. So in this example then, so you've got a diver drops from a cliff 55 meters high. Calculate its vertical velocity as he hits the water, assuming that acceleration is due to gravity, which we would assume, 9.8 meters per second squared. So if you were to do that question then, you've got a displacement, you've got S, you've got A, so you need to work out its final velocity. So the reason we'd use this equation and not S equals ut plus half at squared is because that doesn't have v in it, and v is what we need to work out. So v is the subject because we need to know what v is, so we use the v squared equals u squared plus 2as. When you put the numbers in there, you get a velocity of 32.8 meters per second. You'll have an opportunity to practice all of these when you do the questions at the end of the video. So there is another one, which is S equals U plus V over 2 times T. It is in your equation booklet. I'm sure it's half U plus V plus T. So I'm just going to write it as you will see it in your equation booklet. So a half U plus V times T. again is if you need to work out a U or a V and you have an S or a T or whatever. So these questions you've already done. You've done your vector questions, you've done your acceleration questions. So what I'd like you to do now is go to the problem book, and I'd like you to do the equations of motion questions 1 to 8. Don't worry about the 10 minutes to complete. It's not really relevant at the moment how long it takes, to be honest, but I'll set the task. So after this video, if you practice the ones in the PowerPoint, make sure you get the same answers, and then go on to the questions in the booklet on Classroom page, whatever. I'll post the page, but it's the first equations of motions question. Hope that's okay, guys, and any problems, as usual, just contact me.